Greetings and welcome, friends. Mr. Waddy here. We have been solving systems of equations using substitution. That's what I'm going to do a couple homework problems from page 245 today with you. My hand feels a little bit chilly. It might be a little quivery with my lines. We'll see how this goes. So in solving by substitution, what we want to do is, in looking at both of our equations, I want to target to find the weak spot. I want to solve one of these equations. There's two equations, and there's two unknowns, x's and y's, right? X's and y's. And I want to pick the x or the y that will be easiest to solve. Now, substitution, you could just target any of these, and you could work with the fraction 11/7 and solve the problem. It will still work out, but it would just require you to use a lot of fractions. But the weak spot is going to be any variable that has a +1 or a -1 coefficient. So I'm going to solve this second equation for its x. And in doing so, to get that x by itself, I would add 2y to both sides. Oh, wow. Good times. Here we go. Here we go, man. It's been a weekend. Back to teaching math. This is the life. So let's see. So x equals 2y minus 4. This is called the revised equation. 2y minus 4 being equal to x can now replace x at any time. And I'm going to plug it into must be the other equation's x. Other as in not the equation that I solved for. So I'm going to plug this into the other equation for x. And when I do that, that is step 2. 11 times, and instead of x, I'm writing 2y minus 4. Put it in parentheses like sand in a bag, minus 7y equals -14. And then make sure you write the rest of the equation. All right. So now this equation by itself is perhaps uglier than the other two were, but it's got one benefit in the fact that it only has one variable, one type of variable. So it's actually one that we know how to solve. So let's see. So 22y minus 44 minus 7y equals -14. Let's combine some like terms. I distributed 11. Yeah, so I multiplied 11 by both of those. Yeah, so I'm just simplifying, distributing, combining like terms. The usual. So let's see. So I'll have 15y's when I do 22y minus 7y. Let's see. Minus 44 equals -14. Let's see. Did I give myself enough room before I hit the next problem? We'll see. I think so. Let's see. So to get y by itself, I will add 44 to both sides. Now, you technically could have done this problem 3 other ways using substitution. So you didn't necessarily have to do it this way. This is just the easy way. Divide both sides by 15, and I will get y equals 2. That is only half of my answer, however. I'm interested in the xy ordered pair combination that happens to make both of these equations true simultaneously. So I'm going to take this 2 and plug it in up here for y. Now, technically, I could have plugged it in either of these for y, but this equation is really nice because it's already solved for x, so I might as well do that and not have to solve both of my equations twice, or solve those equations more than I need to. Let's see, where's my scroller here? There we are. So step 3 is substitute this into the revised equation, solve for the remaining variable. So x equals 2 times, and instead of y, I'm writing 2 minus 4. Ooh, 4 minus 4. X is 0. So my solution is then the ordered pair x comma y, so 0 comma 2. And that would be the intersection of those two lines if I was to graph them. All right, so that's how that works out. To do a check, I don't know, I've done enough checks. I don't think I'll take the time to do it. But to do a check, you would plug in 0 for x and 2 for y in this equation, verify that it works. you'd plug in 0 for x and 2 for y in this equation and verify that it works. But you guys have seen me do those before. For sake of time, I'm going to jump right into this word problem coming at you. All right, so here we go. A farmer. I was trying to actually get my wife to do some algebra last night. We were gonna hang some paintings, and I was like, "Oh, you got 2 paintings. You've got some unknown margins. You've got a total wall space." I was like, "You could just do some algebra, measure it all up, and figure it out." And she's like, "You can do the algebra. Like, you're used to this." And so I don't know. I almost had her doing a real-world algebra problem. Almost. It was so close. Let's see. It says a farmer plants corn and wheat. Okay, good for him. On a 180-acre farm, the farmer wants to plant 3 times as many acres of corn as wheat. Okay, so that's a fact. Maybe I'll be able to turn that into an equation at some point. It says write a system of linear equations that represents the situation. And then they ask the question. The question is going to be the thing that helps me define my variable. So to start the problem, I look at the end of the problem. It says how many, so this is not going to be a cost, this is not going to be a rate, this is going to be numerical acres, right? How many acres of each crop should the farmer plant? So my variables will be x and y, or I guess I could do c and w. Let's do c and w. I mean, I use x and y and z all the time. Well, I guess you guys haven't used z yet, but yeah, let's use c and w. Let's say c equals the number of acres of corn, acres of corn, right? And let's let w, dub, equal the number of acres of wheat. Wheat. There we go. All right, so I've defined my variables, right? And I did that by looking at what the question was asking. Now to write my equations, here we go. Let's take our facts. So it says a farmer plants those 2 things on a 180-acre farm. Only those 2 things. So the total acreage is going to equal the sum of the acres of corn and the acres of wheat. So C plus W is going to equal 180. Right? That fact wasn't like jumping out at us, but hopefully you guys can catch that. Let's see. The next fact, it says the farmer wants to plant 3 times as many acres of corn as wheat. So the acres of corn is going to equal 3 times the acres of wheat. Oh, that was a little too many W's there. There we go. Now, it would be so easy to just read 3 times acres of corn, and you'd want to write 3C equals W. But that means that C would have been the smaller number, since I would have had to multiply it by 3 before I got something equivalent to W. All right, so this is tricky. It would have been real easy to write that equation the wrong way. This would have been wrong. This is right. The corn is equal to 3 times the acres of wheat. All right, so make sure you when you write it, look back at what it said and make sure that it actually would make sense. Like think to yourself, which would be bigger, the C or the W? And in this case, the corn would be 3 times as many W's. So make sure with that you're careful. So let's solve this system. So once I've combined my 2 clues to find my 2 unknowns, I can now solve. Let's just solve using I don't know, substitution perhaps. Let's see. Looking at these 2 equations, great place to target would be this, or this. Which is the best place to target though? Yeah, this one, because this one's already solved for C. Isn't that great? Yeah, so step 1 is done. C equals 3W. That's already solved for C. And then step 2, I'm going to substitute this in for C in el otro equation. So let's see, step 2, I'll have 3 dubs plus 1 dub is equal to 180. Oh dear. Oh dear. All right. So let's combine some like terms. So 3W plus 1W Notice I didn't need parentheses in that case because this C wasn't being multiplied by something. 4W equals 180. And divide both sides by 4. Let's see, W equals, all right, so 180 divided by 2 would have been 90. Divided by another 2 would be 45. But I could see you reaching for a calculator for that one. Or, I don't know, doing long division or something. Let's see, so that's my W. What about my corn? How much corn? Plug this in for W in the revised equation. And that's already solved for C. How convenient. So C is going to equal 3 times 45, which I believe is 135. Wow. I had to work so hard not to write degrees at the end of that because I teach geometry. And like 45 and 135, man, it's just, wow. Those feel like angles to me, also from teaching pre-calculus. So let's answer the question. All right, so I've got C is 135. So my answer is he should plant, or the farmer plants, 135 acres of corn. Acres of corn. And 45 acres of wheat. Right. So there's my answer. My answer to a word problem should have words in it. And once you've found your solution to the system, you just simply say, okay, W equals 35. What does that mean? That means 35 is the number of acres of wheat. If you define your variables well, to write your answer, all you do is combine. You actually almost substitute this number in there, and you just say 45 number of acres of wheat. And then you just try to make yourself sound less like a robot. So that's not that bad. Not that bad. And then, it's not a bad idea also just to check and just be like, does that make sense? Yeah, if I added those together, that feels like that would add to 180. It does. Yeah, and this is 3 times as much as that. It's not a bad idea to check it so that if you wrote this equation wrong, even if you did a check back in your equations, your wrong solution would have worked in your wrong equations. So it's not a bad idea just to kind of check the reasonableness of your solution in the context of the word problem. Like if you realized that wheat was bigger than corn, you would have been like, oh no, that doesn't make sense with that red statement. So let me at least write the equations for this one, the variables and equations for this 25. I might not take the time to solve it because I want to finish this video at 15 minutes. I think that'll be sufficient. It says a math test is worth 100 points. Wow, it has 38 problems. Each problem is worth either 5 points or 2 points. And okay, here's the question. How many problems of each point value are on the test? So my variables should be X is the number of 5-point problems. Okay. And Y is the number of 2-point problems. All right, so you guys see how I got around to the point of writing these variables? I just look at what question were they asking, and then I wrote unknowns that were in those terms. All right, so to write my equations, I love using this red and green to highlight these. Okay, so it says, here's one fact. A math test is worth 100 points. That's going to be the tougher equation to write. And has 38 problems. Math test has 38 problems. Okay, that's the easier equation to write. I'm going to write that one first on my second line. So if it's a total of 38 problems, X is the number of these kind of problems, Y is the number of those kind of problems. The total number of problems is 38, and it would equal the sum of both of those kinds of problems. So X plus Y equals 38. All right? But how about the green equation? That one's going to be tougher. It's worth 100 points. So how could I write an equation that relates 100 points? Oh, and then, oh, here's another, look at this. My green equation is related to worth. Aha, here's another word, worth, showing up. Each problem is worth either 5 points or 2 points. So I should somehow use that fact. I didn't underline all of the things necessary to answer that just yet. So how could I do this? Anyone have a thought of what could go here? Well, if I take the number of 5-point problems and multiply that by the points per problem, this would be the total number of points on that section of the test. And then plus the number of 2-point problems and multiply those by what they're worth. This would be the number of points on that section of the test. And if I add those two sections together, I should get 100. All right? Yeah, a little bit tricky. All right, that's as far as I'll go for today. Thanks for watching, Internet friends.